Hi, and it's with great pleasure that I'd like to welcome Alan Barnard. Hi, Alan. Alan's joining us from the USA this morning for him and afternoon for me when I'm recording it. Hi, Alan.
Hi, Ian.
Hi. Alan, some of you will recall in Module 4, Alan provided us a couple of presentation recordings of his relating to the use of simulation modeling to describe both projects and project portfolios to get some insight into how those operations behaved. That's something that we'll be drilling down to in this discussion between myself and Alan. Before then, just want to introduce Alan. Alan's the Chief Exec CEO of Goldratt Research Labs. He's one of the world's leading thinkers about decision science and theory of constraints, as well as the multinational, multi-billion large organizations that Alan works with to help get some insight and to continuously improve their operations and make almost seemingly impossible decisions. At the other extreme, Alan's done a lot of work with individuals. He developed, from the roots of theory of constraints, thinking processes, the Procon Cloud, a structured, app-driven approach to help a wide range of individuals make better choices and better decisions. Does that reasonably summarize your life and your mission, Alan?
Yes, I think so. I think the interesting part for the viewers might be just a connection between decision making and theory of constraints. There's two obvious connections. The one is that when it comes to decision making, there is a bottleneck that we have when it comes to decision making, the things that's limiting us from making better, faster decisions. We have an attention bottleneck. We can only pay attention to so many things at a time, one thing at a time. So as soon as I'm talking about decision making, if we become decision fatigued, it normally means that we've run out of attention and that we start defaulting to the safest possible option, which in many cases might be to do nothing. It feels like doing nothing is the safest possible option. So that's one connection, is by studying our limited attention and as a bottleneck, as a constraint, and how we waste it when we make bad decisions and we have to do rework. That's a very clear connection. But there's another less obvious connection, which is if you think about a production environment and you are quoting your customers, say 3 months lead time, so 90 days of lead time. In a production environment, the actual work time or touch time in a 3-month order is often just a few days or maybe a week or two total production time. So there's this huge gap between the total time and the actual work time. And what we're constantly trying to do is to try and identify the avoidable delays so that we can reduce the total time to be close to what the actual work time is. So that the work is never waiting for a resource or any other thing, it just flows through the system. Now, in a project environment, the touch time is more like 50% of the total, but it still means that there's theoretically 50% of the time that we've added to the process that we could have avoided. If you think about it from a decision perspective, and you say, if we recorded the actual time it takes us to make a decision, compared to how long it actually takes us to make the decision, you'll find a similar type of shape and even more extreme than in the production environment. Often it takes us 3 months to make a decision, whereas if we actually look at the time to make that decision, if we had a full kit, right, it would be a few hours. So the amount of time that we can save by thinking about decision making as just another packet of work that has to be completed, we're comparing the total time it took us to make that decision from the moment that we realized we had to make a decision until we made a decision. That would be my total time. The actual work time would be, okay, I have everything that I need. I'm sitting down. How long will it take us? And that's the magnitude of time that we could potentially save if we think about decision making as almost a kind of a mini project.
And I think that's one of the pluses in taking that approach, where you're focusing on the delays and the waste, is it doesn't start to become personal. You're not attacking potentially or seen as attacking somebody's capability to do the job. You're focusing on what gets in the way.
Yes. And it could be, the reason why we've got a delay in decision making could be we're waiting for full kit, right? So there's still some piece of information that I need in order to make that decision. So for example, if the decision was, I have to commit to a time, how long am I going to quote on this piece of work, right? It could be a very simple task, one task, it could be a whole series or network of tasks. But the first decision is, I have to make a commitment. How long am I going to commit to? Well, for that, I need to know what the network is, and I need to get estimates for each portion of the network. And then I can, so when I'm looking at the delay, is to say, how long was I waiting for all the information to be ready, for a full kit to be ready before? But what if all the information was already ready, but I still haven't given the answer? So now it could be one of two things. It could be a knowledge gap. I don't know how to translate the information I got with the individual estimates into a commitment. So would I just add them all up and get a number, or would I add them all up and add another percentage to that if I wanted to be extra? So there's some kind of way that I normally create commitments, right? So that could be a knowledge gap, but it could also be a confidence gap. So I already know the formula, so I could tell you the sum of all of these is 100 days. I should have committed to 100 days, but I'm not confident to commit because there's a lot of uncertainty and variability. And when I know those things, was I waiting for full kit? Was I waiting for the knowledge to arrive to tell me how to do it? Or I knew how to do it, but I just didn't do it because I wasn't confident. That information about what's causing the delay is really important from a decision-making perspective. And what are we trying to do to solve that problem?
Yeah, one of the things that came to my mind, Alan, when you were going through that, is something we focused on during the master's program, is the fundamental difference between some of the exploratory, the early stages of projects. In fact, the things that some schools of thought don't even call a project at all.
Yes.
We take the more holistic view that those early stages are an integral part of the project, but they're fundamentally different. And in those, I might suggest that sort of some of the non-productive time is necessary, the trial and error. And it's only with hindsight that you say, well, if we'd have made that decision at the beginning, it would have been much faster. But the actual process of trying something, discovering what doesn't work, you could say in those circumstances, it's value adding. But when we get into delivery and implementation and operations, where those sort of exploratory, iterative decisions have been made, we've got a very different scenario. And that's what I'm assuming is a lot of the work that you've been doing, looking at
absolutely. Just
waste.
we've had a number of discussions about this. For me, the two holy grails when I do an analysis of a project, where I do it just manually looking at a Gantt chart, and I'm first of all looking at the plan, and then later I'm looking at the plan versus the actual, whether it's right at the end of the project or as I'm going through. Essentially, I'm trying to answer two questions: is why did something got delayed, and how can I fix it? So obviously it assumes the what part. I am tracking the delays. Once I know the magnitude of the delays, to say this project was originally planned for 100 days, it took 120 days. So there are 20 days of unplanned delays that somehow creeped in. But I can also say, even if it took 100 days, of that 100 days that it ultimately took me to complete a project, which I expected, that was the commitment that I made, there was an additional 20 days that would have been avoidable delays. For example, if I didn't have resource constraints, maybe that 20 days there could have been avoided if I just had enough resources at the right time. So I'm trying to quantify the amount of avoidable delays that took place. And then I'm trying to understand why did they take place and how do I best fix them? What's the simplest rule that I can use? Where we are making a difference is we're trying to differentiate between a delay that happened because of pure task variability. And that variability could be that it just took us longer to complete. We underestimated the complexity, but it could also be that we underestimated the number of iterations or the duration of those iterations. But we would lump all of that stuff under expected or task variability compared to something else, which is waiting for full kit or waiting for a resource to become available or waiting for resource, including a management attention to be available.
Cool. Let's start off, Alan, by looking at your sort of overall experience, because I know you've told me about quite a few of the experiences and organizations you've worked with, looking at projects and portfolios. Do you see any common theme emerging? What if you were to do a top 5 or a top 6 leverage points where most organizations seem to have the largest opportunity to improve? Where would you put those?
Yeah, I think it's the first thing that I did was I did a classification on the type of decision mistakes that we can make. So we classify them into planning decisions. So these are all the decisions we make before we start doing any work, right? So for example, is the resources that I've allocated to a specific task, that would be a planning decision.
Yeah.
So if I allocated too few resources compared to what I would have had available at that time, that would be classified as a planning mistake. And I can then go back and rerun that and say, if I had corrected that mistake, so there was a task that I assigned 2 engineers to, but in execution, there were times when we had 4 people available that if I had assigned all 4, I could have done it faster. So the first part is I look at planning decisions and the mistakes that we make in planning. Another planning decision would be, am I going to control the work in process? Do I start everything as soon as possible, essentially ignoring any sort of capacity constraint? Or am I going to be controlling the work in process, the release, not starting everything as soon as possible, but when a specific resource might become available? And again, there, I want to be able to go back and say, was the delay that I noticed because of this planning mistake? So there's a bunch of decisions, and I'll share the classification with you and the students that they can have a look at. There's fundamentally 2 main mistakes, big decisions and mistakes that we make in planning. But then there's also 2 big decisions that we make in execution and mistakes that we make. So 2 big decisions in execution. This is decisions we make while we are doing the work. So you can imagine one of those decisions would be, how do I prioritize? Would be a key execution decision, right? Do I prioritize first in, first out, or a more sophisticated metric like we use the percentage of buffer consumed would be another way of prioritizing. Another way would be, if I have 2 tasks, pick the one that's the shortest, do that one first, and then do the longest one, or vice versa. Now, in a simulation environment, I can try out a number of these prioritization rules and see which one gives me the best outcome. Another rule in this in execution is, do I do any form of batching? Do I simply do them one by one, or do I wait until I have a few of them and then do them together? But that's now causing a delay, waiting for me to reach the minimum batch size, for example. And then on the execution side, it's essentially, what am I tracking as variances, and what options do I have to reduce those variances? So if I'm tracking variances everywhere, right, and I'm constantly reporting variances everywhere, it makes it very difficult for somebody to know what to fix, because they might have a decision rule that says, fix the variances that's the largest, rather than fix the variances that cause most of the delays on my project. If I had a very simple structure, serial, the answer to those two questions would be identical, right? The longest variance would also be the variance that caused most of the delays. But as soon as I have a network and I have resource contention, it becomes very tricky to find out which variance caused the longest delay on my critical chain and fixing that. And that's an execution decision, as what events am I tracking and reporting, and how do I act on that? So if I'm tracking the wrong stuff, that's an improvement mistake. But even if I was tracking the wrong stuff, but I was acting in the wrong way, that's again an improvement mistake. I've added another resource, or maybe I've taken resource away because, like in a recent project, we found out that this company was looking at a specific group of engineers. The average utilization was around 40%. They had 10 of them, so they literally wanted to take at least 5 out, maybe even 6 out. And what we showed them after running the simulation is the number one reason for the delays on their projects was not having enough of these people at the right time. So their average utilization was very bad, but in specific time periods, it was way above the 100%. And all that would have happened if they had cut that resource by 60% or even 50%, it would have just contributed to more delays during that time. Essentially, the project system would have taken longer to recover when those people became bottlenecks.
The problem of looking at averages rather than...
Exactly. So as a sort of a summary, I think it's important to start looking at what are the decisions we make in planning versus execution versus improvement, and to think about the rules that we have within Agile or Scrum or critical chain project management or traditional waterfall as simply rules that we use for planning, execution, and improvement. And if the delays in my environment are being caused by a rule in critical chain, right, then putting in critical chain would make it worse. If it would be fixed by a rule that I have in critical chain, it would make it better. Like a simple thing in terms of work in process reduction, right? Controlling work in process. We had a recent case where a customer implemented critical chain and the outcome was really bad. Things took longer, they got less done. And the question was, how can it be? We implemented critical chain correctly. And it was because they were in that, extreme case where they were already starving the work, critical resources of work during critical parts of so by controlling the release of work, they just increased the level of starvation, right? Now, we know that that's an uncommon situation. Most of the time, if we think about, do I have too much work in process or too little? Most of the time it's in too much. So most of the time, by cutting work in process, I'll get back to that sort of Goldilocks zone where I just have enough. But in their case, they were already on the left-hand side, where they just had too little and it was causing starvation. So by cutting that, they would have gotten a worse result. So for me, it's never about what set of rules to use. It's first of all understanding how much delay is there that's avoidable, number one. What's causing those delays, and then to think about what methodology has a rule set that can fix that problem or reduce that problem. That tells me which is the best way of going forward.
Interesting. And do you find any patterns, or is it that the types of organization you look at, Alan, have such a wide, diverse mix that it could be anywhere? Or do you see some patterns emerging? Because rules of thumb are useful, but as you say, in some circumstances, they're the wrong thing to do. Right.
So we definitely do see, if I think about 100 days as your duration, right? Now, 50 days of that 100 days would typically be actual work time. So the only way to improve that work time component would be in two ways. a process improvement that can reduce my cycle time, maybe through automation of some of the work, or by adding other resources, right? Those are the two things. But let's just say the other 50 days that we've got there, how much of that would have been avoided compared to natural variation? And we could make a split that says of that 50 days, maybe 50% of that is natural variability, but there's at least 25 days that we could have avoided. So I'm taking that 25 days and now thinking about if there's, say, 5 decision mistakes that could have been made, they could each contribute 5 days of that 25 days. That's one way that I could see it, which means that if I had 5 rules to prevent those 5 mistakes, implementing rule 1 would have saved me 5 days. Or 4 out of the 5 days. Implementing rule 2 would be giving, but that's not reality. Most of the time, what we see in reality is that of that 25 days, most of it is coming from 1 or 2 mistakes, either in planning or execution or improvement. And that's what I'm looking at is I'm trying to quantify, is the avoidable delays 5 days, 25 days, 50 days. And of that, what makes up the biggest portion? And that tells me which rule to go and implement first.
Okay. And it sounds like whilst sort of there are frequent ingredients, each organization you come to is like a different recipe. So some have more one, some have more the others. Can you share a few examples of organizations and the different kinds?
At a very high level, if you think about the total lead time for project or for production, that is made up of 2 components. The first one we can call demand lead time, the second one supply lead time. So the demand lead time is from the moment that there was a demand for this specific work, right? Until we actually started on it. That's my demand lead time. So if you imagine a retail environment where somebody walks into a shop, they buy something, right? So now there's none of that product available. How long before they place the order on the supplier is the demand lead time. The supply lead time is from the moment that the supplier gets the order until they get it to us. That's the supply lead time. So I'm looking at that whole thing as say 60 days, and I'm placing orders once a month. That's my demand lead time, and it takes them about a month to get it to me. So if I'm thinking about what's the fastest way to get that 60 days down, I say, what if we just ask them to place orders once a week? In the same way that if you're in a project environment, you want to try to see there's a packet of work that's going to be required. How long does it take me as a resource doing that work until I know that it's due, that somebody needs me to do some work? That would be classified as demand lead time. As soon as I know about the work, then it's supply lead time. And that supply lead time, what I like to do is to break it up into 3 components. So I'm looking at the supply lead time as the total time in the system, in my system. And there's 3 components of that. There's time in backlog. There's time in process. So the task is now with me, and that's my pure cycle time, essentially. And there's time in queue. So if I have 2 steps in the process, right, then all the time that task is waiting for me to start would be time in backlog. As soon as I start the work, then it would be time in process. And if it's waiting in queue between process steps, then it would be waiting in queue. So again, I'm trying to form in my mind, I now have this 30-day task, which is my supply lead time, right, the generic name. Of that 30 days, we generally have some kind of an assumption, like what we do in production. If I quote you 30 days, I'm never assuming that you're the only person that I'm doing work for. If I quote you 30 days, most probably I would have assumed that probably about 15 days is the worst case scenario in terms of time it takes me to do the work. And about 15 days is my allowance for backlog. So I'm assuming I get to work. It'll probably take me 15 days to run through the backlog until I get to your task. And once I start, it'll take me 15 days to complete it. So now I already have in my mind 15 plus 15. When I'm in execution, I can monitor whether that assumption was correct, because it would change my commitment that I'm making, right? So if at any point in time I'm monitoring and seeing I've got already 45 days in backlog, and I know that it takes me about 15 days to complete the work once I start it, there's no way I can be quoting 30 days lead time anymore. I would have to quote my backlog, my current backlog, plus the time buffer that I've given myself, which is 60 days. So that's true for both a production environment, but also project environment. So I'm constantly, when I'm doing analytics, I'm trying to figure out how much of the total lead time is avoidable. And of that avoidable part, where am I losing the time? Am I losing it in backlog? Am I losing it in queue between the processes? Or am I losing it inside of the process itself? So if I get analytics back that says, of that 30 days, the backlog, the time in backlog that the work was waiting was 2 days. The time in queue was 2 days. The rest of the 30 days, 26 days were all in process. I know that I need a process improvement here, or I could solve it by adding more resources. But in most cases, it's the opposite, right? The in-process time is maybe only 5 days or 10 days, and there's 20 days that's in queue. There's almost nothing in backlog, because as soon as I get a task, immediately I start with it and I'm multitasking. So that to me is what I would encourage your students to do, is to stop thinking about critical chain or agile or waterfall as the solution that always works, but to think about it as these solutions are all based on principles. The principles are universal, which is focus on flow time and flow rate, right? That's my number one priority, is how do I improve my flow time by reducing avoidable delays? How do I increase my flow rate by avoiding capacity losses? And then to say, okay, now that I know that that's my goal, what is the mechanism I need in order to reduce the flow time losses in my environment? Not generically, but in my environment. And for that, I need to know at least, is the major delays happening in backlog? Is it happening in process or in queue in between the processes? And as soon as I have that answer, I know which set of rules will work best.
Okay, yeah. And how the sort of different perspectives to look at that problem and issue, because the same issue of flow happens in detailed day-to-day work, through single projects, and also at the portfolio level, where there's a number of relatively independent projects going through an organization, and an organization will want to get as much done as possible, whilst at the same time using a range of inherited organizational rules for their limited resources, which will often be things like, let's keep people busy, as you said, let's not have resources at 50% productivity, even though in your example the system needed that. So could you share one or two examples from your experience, Alan, where organizations were struggling with that, and how sort of giving the managers a tool to play with that wasn't their real system? Because many project systems, you're talking years to see the effect, and you can't play with one variable and hold all the others constant. So the causation is actually quite difficult to see. So And that's a field where simulation and modeling can help give people confidence. Have you
Yeah,
got
so
a couple of different examples you can share with us?
sure. We had a case study that we presented already that, you know, we can share with all the attendees. It's a big gas turbine, you know, manufacturer. They were delivering a number of different products, all the way from just designing one part to designing and building that part to designing and building the whole system. So there are a whole bunch of different size of projects in their portfolio. Some small projects, some medium projects, and some large projects. So the first thing that we wanted to do is to say, if I'm studying this thing, I need to find some way of normalizing the data, right? So if I was, for example, controlling work in process, I can't control work in process at a project level when all the projects are different, right? Because I will say I have a project limit. I want to control the work by 5 projects. But if I release a large project compared to releasing a small project, it will have a massively different impact on my utilizations downstream. So normally the first thing that we do is we try to normalize everything. So a very simple categorization that said, a large project is essentially 10 small projects. A medium project is 4 small projects. So now I've converted their portfolio into the number of small project equivalents, right? And that to me is a really interesting starting point to say, okay, I've now got a baseline. They've given me their plan, and there will be a plan under one condition: they have to make a commitment. Like, as soon as I have to make a commitment about lead time or budget, it means that they need some kind of plan. So what's generic in many environments, even with the most advanced companies that we work with, they often tell us, but you don't understand, you know, we don't have very sophisticated or detailed plans. You say, but did you make a commitment? Yes. How did you get to that commitment? That was your plan, right? And in that plan, you considered both task duration, and you considered probably some level of resource availability. So the first step in the process is just to get that plan in a shape that we can import into our simulation. We have now all the tasks, the sequence of those tasks, their dependencies. We normally have one number, which is the number that they use to make a commitment to. And we have the resource availability. And what we can do is to say, just tell us what's your expected level of variability at the task duration level.
Okay.
Right? Once we have that, they said they thought that this task would take 10 days. That's what they used to come up with their commitment. That was their planned duration. Say, okay, tell me more about this 10 days. What's the best case? What's the likely? What's the worst case? As soon as they give me those 3 numbers, I can now simulate that task as a triangular distribution. And what I want to do is to say, if we get a real world scenario, real world means there's real task variability, I want to know what the outcome will be. But I can also simulate a perfect world environment, which says, I'm assuming that every task will be completed in the planned duration, but it can still take longer because of resource unavailability. So I have a plan with a baseline, and I can now run 2 simulations, one perfect world, one real world.
Yeah, I was going to say, just for those of our students who are aware of and have done some degree of common Monte Carlo simulation, you're taking account of 2 different interruptions there, the inherent distribution of time, but also the availability of a resource.
Exactly.
Whereas a conventional project, Monte Carlo, would not take account of the latter, would it?
Exactly, and it wouldn't be able to take into account specific types of behaviors, right? So, for example, if I have in my environment, I know that there's evidence of Parkinson's law, right? That has a big impact on how variability is transferred.
Yeah.
So Parkinson's means I can't benefit from early completions, but I will be penalized by delays. Whereas if I run just a traditional Monte Carlo and I don't have that behavior in my simulation, it would assume that statistical fluctuations will cancel out, which will create an unrealistic expectation.
Yeah.
But there's another reason why statistical fluctuations won't cancel out. Imagine I'm scheduling my project with specific start and end days for every task, right? And I'm issuing jobs for every task. So my first task is 10 days long. My second task is 10 days long. My first task, I'm lucky, and I managed to complete it in 8 days. But my second task was planned to only start on day 11. So what's going to happen now is that second task, the person will only get the job card, right, on day 11. And I'll go, am I ready to start? Yes, the preceding task is complete. I can start it. So again, I lost 2 days because I'm not allowing early starts to take place.
Yep.
And that's an important part, is with simulation, we can simulate that. Whereas if you do traditional, Monte Carlo, or even if I'm trying to sort of imitate Monte Carlo inside an Excel spreadsheet, it's very difficult to include fully this dynamic unavailability. Because I finished early, was the resource available at the right time on day 9, or is the delay because I don't allow early starts to take place, or is the delay because of Parkinson's? So that's the benefit that we get by doing full dynamic simulations, is you can actually incorporate all the impacts of both variability as well as interdependency, either because of prerequisites or because of resources that is shared amongst various tasks.
And you can more easily switch that on and off and play with different scenarios. And
like I could say that you've got a plan that shows 100 days. Let me run it in perfect world, which means I'm taking away all the variability at the task level, and I'm only considering capacity constraints. So that would be going from a critical path essentially to the critical chain, right? How long would it have actually taken if I had considered my resource unavailability? And I'm saying, oh, I've gone from 100 to 120 days. So there's 20 days there that if I had enough resources, I could have saved. Whereas if I run it and I say, okay, you planned it 100 days, I'm running in the perfect world, and it took 100 days, right? Now it's all about understanding how task variability impacted my total lead time. And now if I run it in real world environment, and I notice that I've gone from 100 days to 130 days, I know that that's the problem. The statistical fluctuations are not canceling out, right? Now, why is that? It could be because I have too simple of a structure, right? They can only cancel out if I've got a lot of tasks that each has variability, and some of them will take longer, some of them will take shorter, and over time they will cancel out. But if I have only 2 tasks, it might be that I was unlucky that both tasks went late and now I'm late. And if I rerun the simulation again, so I would have to run 100 replications maybe to see if they're canceling out, compared to, I know there's Parkinson's, or I know I'm not allowing early starts to take place. And I could have predicted what would have happened there if I had enough there. And I think that's an important part, because, for example, if we start looking at the benefit of aggregating a buffer at the end of my project rather than buffering individual tasks, and there's some assumption that I can reduce the amount of buffer because I benefit from aggregation, that's an assumption I need to check in my simulation. Is there enough tasks with enough random variability that by buffering them together with a project buffer, am I going to be able to save? And the benefit of simulation is I don't need to understand the mathematics behind it, right? I don't need some sophisticated way of calculating my buffers based on it. I can simply run it and see how much of the buffer that I really need.
Yeah, see what happens.
Yeah,
and with the gas turbine example, which was quite a large portfolio, what kind of things did that bring out first time? Because presumably you first ran the simulation with what they were planning
we
to
ran
do.
the simulation. They gave us a portfolio that was 5 years long, that was supposed to generate about $250 million worth of profit. Mm-hmm. So we read that plan into our model. We ran it in perfect world and then in real world. And we noticed that even in perfect world, it was going to take more than 5 years, around 6 years. And in real world, it's going to take about 7 years. And rather than make $250 million, it was going to lose them about $150 million. So now we have a good way of checking how much of the delays are going to be due to purely capacity constraints and how much of it is purely because of variability. And essentially what we realized what was happening and why they initially approached us was for 2 reasons. They said, we are quoting standard lead times for these various projects because it's, they've built these gas turbines before. So even though it's more like a project than a production, mm-hmm. It's sort of standard work packages. They know about how long it would take. And they would be quoting, say, 9 months for this gas turbine manufacturing to take place.
So the individual project was feasible. It wasn't unreasonable or optimistic.
It was feasible, but what they were ignoring was there was a backlog that has been developing because the demand was greater than their capacity. And the people that were quoting lead times were essentially ignoring the backlog. So they already felt uncomfortable that said, we are already starting to be late, but we have no idea how to quote more realistic lead times. And we're terrified to get into this vicious cycle where we start quoting longer lead times, but then we release projects earlier. And as a result, we increase our work in process, which is, on my definition, is not actually the work in process. I'm increasing the work in queues, mm-hmm. right? Yep. And that to me is the balance, is by increasing the work in backlog by maybe 10 days, am I saving 20 days in queue? Mm-hmm. Because that will then increase my throughput. If I use Little's law that says my throughput is equal to my work in process, which is actually the total time in the system, mm-hmm. my working system, over the lead time, which is the total time in the system, I want to check if I reduce my amount of work in the system, both in process and in queue, will that give me a disproportionate reduction in my lead time? If I get the same reduction, if I cut my WIP by 25% and my lead time goes down by 25%, my throughput can't go up.
Yeah.
Right? But what can happen is I cut my WIP by 25%, my lead time doesn't change, and now my throughput goes down by 25%. And that's what was happening in that extreme example that I shared with you. So essentially what we found with the gas turbine, the first mistake that they were making commitments, ignoring capacity and ignoring backlog. Okay. And you have to consider both of those. So what we could do is to rerun the simulation and to say, what if we didn't ignore capacity and backlog in our making commitments rule that we apply? Let's rerun it. And of course, now we're going to be quoting longer lead times. But the benefit of that was they had penalties for late delivery. Mm-hmm. So to say, if we could correct that, not past projects, but any new ones that we're creating, right? Because they were already partially into that 5-year period, at least it will save us the penalties on the delays, on the late deliveries for any new project that we're starting, if we could still change a commitment. Okay. If we can go back and change a commitment on the project that we've already started, we go back to the customer and say, listen, we quoted you 9 months, but based on our current backlog and capacity, we can't finish this in 12 months. We'd like to renegotiate. Then at least we would save the penalties on that one and give a more realistic number in terms of the resources that we would need. So what we started doing was, by analyzing the current portfolio, we were able to isolate what are the biggest mistakes that they were making. And definitely the first mistake that they were making commitments without fully considering backlog and capacity constraints. The next step was,
did they feel they could still win enough business? Because there is that sort of sales dilemma that if I tell the customers the truth, they won't even give me an order. How did you factor that in?
Yeah, so the normal way that you would look at that is to say, are all the customers time sensitive or not?
Right.
Right. So you want to segment your market immediately into ones that are time sensitive and ones that are not time sensitive. So ones that are time sensitive, if you go back to them and you say to them, listen, I quoted you 9 months. Realistically, it's going to take us 12 months, right? Now, I can tell you now that it will take 12 months, or you'll see that it takes 12 months. That's how accurate the simulations are, right? So when you want me to tell you the truth, now or in 9 months' time when we didn't deliver, and I'm going to tell you there's probably another 3 months of work. When you tell, and most customers will tell you, in fact, all of them will tell you, I want you to tell me the truth right now. Now, here's the situation. I've now quoted 12 months. If this company was not time sensitive, and I said to them that I'm not going to change the price that I quoted you, I probably won't lose the work, right? So in that case, it wouldn't matter. As long as I don't change the price. If I go back and say I have to recalculate the price because it's now going to take 12 months of resources, then I might still lose the work.
Okay. Yeah. So some of this was coming from their own staff's habits. We always quote 9 months.
Exactly, because that's what we've always done.
Okay.
Yeah, and that's a simplifying assumption, because who the hell can check right in detail what must be my current lead time? Actually, all I need to know is what's my backlog. Right? How long does it take me to do this process? What will make me feel real? But then I have to add the backlog to that. So the second one is, I quoted 9 months. It looks like it's going to take 12 months. And I've told my client this, and they tell me, listen, I need it in 9 months. So now I have an option to say, listen, I can do it in 9 months, but it will cost more. If they have an alternative, they will go to the alternative, right? But I can warn them to say, don't be surprised if your alternative is going to be late. Right? So I'm willing to guarantee the 12 months. That's what I'm willing to do. I'm so confident that I'm willing to guarantee the 12 months. So if you're time sensitive and you really cannot afford to have it take more than 12 months, and normally they add their own buffer, right? So they would normally say, the supplier quoted me 9 months, I'm probably committed to 12 months. So if my delay is going to be within their own buffer, it shouldn't make a difference. If it does make a difference, they have the two choices. They either go to an alternative at the same price, or if they don't have an alternative, they can stick with me, but at a premium. And that will allow me then to add the necessary resources. But I can test that assumption in my simulation. I can sit with them and say, if you really need it in 9 months, here's what we're picking up, what's causing most of the delays. It's a resource problem. So if I add these additional resources, right, I'm not going to quote you 30% more. I'm only going to quote you how many additional resources that I need. And that might be, 30% more resources on my capacity constraint area, which might be only a 5% increase in the total cost of the project.
And did you find that with your gas turbine example, that there were unacknowledged or previously unknown critical research constraints?
Absolutely. And the other thing that we found that was very interesting was in our simulation model, we can build in all the penalties for late deliveries. We can build in the bonuses for early completion. We obviously have all the variable and fixed costs. So if you think about the prioritization of that portfolio, they've given us their pipeline, right, with the priorities already in there. But what we can do in a simulation is to say, what if you change the priorities to work on those projects first that has the biggest penalties for late deliveries or the biggest bonuses for early completions, and those that are not time sensitive, you do later. That would be a way of both optimizing my portfolio in terms of time, but also in terms of profitability.
Okay, interesting. And what about some of the ways that they were operating? Did you, because I think initially you said the core problem was simply they were taking too much on in the short term and not spreading it out appropriately, driven by the commitments they've given. Were there other things within how they operated that made life?
There was definitely two things, both internally and external work that was being done. So, you know, a lot of the activities were not just done internally, but was outsourced to others. And we did notice that there were both evidence of Parkinson's as well as not allowing early starts to take place. So that was our next thing of attack, is to say, if we remove Parkinson's, so we essentially are requiring honest reporting. We tell the supplier, if you finished early, please tell us. If it's going to take you longer, please tell us ahead of time, right? So report to us the number of days you expect to be remaining. Don't tell us percentage complete all the way, you know, until 80% complete, and then it gets stuck at 80. That's not useful information. We need to know, you've told us it's going to take you 30 days, right? But as soon as you start with a task, you'll get a better understanding. Was that a reasonable number? So after day 5, you've really unpacked it. You've realized, holy smoke, this is much more complicated than we assumed. I expect you to get on the phone immediately and say, there's not 25 days remaining. It looks like it's 35 days. Give us that information. We put it back into our schedule and see if it makes a difference, yes or no. And if it does make a difference, we're going to come back to you and say, is there anything we can do to help you get it back to 25 days?
Okay.
Including potentially paying for overtime, etc. So that was our next portion of attack, was to say, are there any situations that can cause early finishes not to be capitalized on, either because of Parkinson's or literally I've issued you with a job card and it had a start date on it, right? And even if the preceding task was finished earlier, you wouldn't start it earlier. I want you to be authorized that says, as soon as you know that the prerequisites have been completed, you can start earlier, because that will allow us to recover some buffer. But then the next step that we found was that it was also clear that the prioritization wasn't working, is that people were almost randomly deciding, when I have more than one task available, which one to do. And we could simulate that to say, if you have an assembly type of operation, each of these feeding paths are using different ways of prioritizing, guess what will happen? The chances that you'll have everything to complete one project is rapidly approaching 0. So what we did for them what would be the simplest prioritization mechanism if we didn't have the opportunity to implement something more sophisticated, like using project buffer status as a single priority system. We said, we're going to publish the priority of the programs. And if ever you have 2 tasks waiting in front of you, you look up at that banner and say, program 1 is the highest priority, and only then program 2. So do the tasks in that sequence. And if everybody's following that same holistic prioritization, we'd have flow taking place. Whereas if you randomly allow them to pick the priority, whatever mechanism they choose, whether to do the shortest one first or the longest one, or the most profitable client or the least profitable, all of those things are just going to create random prioritization that really will hurt me if I'm in any kind of assembly type of operation. And that was the next one. And again, we could simulate the benefit of doing that first. And if it saved a significant amount of time, we said, great, that would be the next rule to implement.
Okay. And coming on to the broader question of simulation, Alan, because some of the things that you've just mentioned, as you said earlier, are some of the generic principles about full kit, clear prioritization, etc.
Yes.
Were there elements that the leaders of that organization sort of didn't believe life could be that simple, was uncomfortable in sort of implementing rules of thumb? Did they need the model to convince them that they were the right things to do? And how did that go?
Yeah, I think there's two parts to it. The first part is, what is going to happen, right? And of course, you can wait for reality to give you that answer, but they were already starting to feel uncomfortable. They realized they're going to be late. They're going to make much less money than what they expected, but they didn't know how to quantify that. How late are we going to be? How much money are we going to make less, or how much money are we going to lose? So the first benefit of the simulation was to say, we've taken everything that you've got currently in your plan, right? And we've pressed the play button, and we've just added the variability in there. So that's the difference between the perfect world and the real world. And they were shocked that 5-year portfolio was going to take probably about 7 years to complete. Best case scenario, if they were very lucky, was going to be around 6 years. Worst case was around 9 years. The likely number was around 7 years. None of those were good answers, right?
Yeah.
Because all of them showed that they were going to lose money. Now the next question is there avoidable delays and avoidable costs that is happening, avoidable capacity losses that's happening, that just by changing the rules will allow me to do much better? So that's now the second portion where simulation can bring in to say, I can show you by making a different commitment, how much benefit is this going to give you? Or by changing the way that you prioritize, how much benefit is that going to give you? Or by just stopping Parkinson's or allowing early starts, how much benefit is that going to give you? And suddenly you start seeing, wow, that 7 years of likely number drops down to 6 years, right? That's a huge benefit. That's a whole year of cost that we would have saved. But it's still not getting us to the 5-year period. And to get to the 5-year period, what we can then do is the next step that says, okay, we've tried out just by changing the rules. But what we haven't tried out is 2 additional things, which is, are there any projects there that we now realize that is not going to be profitable at all? That it's best, if we haven't started them, to go back to the client and say, we can't help you, right? Because that will reduce the demand and essentially take very quickly our system out of chaos, out of a system that's very capacity constrained to one that's less. So that's one option that we have, and we can test it. We can say, let's remove this out of the pipeline and see what will happen. Or let's move it all the way to the end and see what will happen. We will quote them a different lead time, of course, if they still want us, because that's very seldom we'll do that. We won't go to the client and say, sorry, we can't help you. We can say, listen, we've got a massive demand problem at the moment. We can help you, but only in 4 years' time or only in 6 years' time, but we'll give you a discount if you're willing to wait, or something like that. So we can simulate all of that. The other one is, of course, adding other resources. And here's a really important part that the simulation is helping us to do. If I didn't have a simulation and I just had a plan, whether it's sitting in a project management system or just in Excel, all I can do is I can calculate 2 things. I can calculate my average utilization, and I can calculate the utilization during peak periods.
Mm-hmm.
So I can see that, over this summer period, we're going to have a high demand, more than what the resources we've got available. But it looks like we have enough resources, so maybe they'll be able to catch up.
Mm-hmm.
What I can do in the simulation is I don't have to look at utilization. I can look at which resource is causing most of the delays. And that could be a resource that have very low average utilization,
mm-hmm.
but periods where there's big spikes and they just don't have enough capacity to catch up in time. So that's the next step that we can then, the simulation will then say, we currently have 4 designers. What if we made that 6? And
mm-hmm.
we can simulate that. Another thing that we can simulate that many of our clients are starting to look at is to say, we can simulate if all your resources were fixed cost resources
mm-hmm.
compared to some fixed, some variable,
okay,
compared to all variable. What if you only paid for resources when you needed it? How profitable would that be compared to all fixed? So we can allow them to play around with different options. So maybe I shouldn't hire 10 designers. I should definitely hire 4 designers because I almost always need at least 4. But between 4 and 10 is where I need that flex capacity. And maybe it's worth my while to hire them at a 30% premium, but only pay when I need them, compared to hiring, maybe 8 and then have 2 too little when I really need them, but most of the time I have 4 too much. So all of those we can simulate that. What if we did this? Is the outcome better? And then it's important to know what's the reward function or the objective. Am I trying to reduce time? Am I trying to reduce cost? Am I trying to improve reliability?
And presumably within a model like that, Alan, if there were some either concerns or actual differences in quality and capability between the in-house and the hired in, that also could be part of the simulation modeling to say, well, yes,
absolutely.
It would be cheaper, but they might not be good enough, or vice versa.
Yes. And again, you can build in things like one of the largest SAP projects we ever did. It was a $5 billion SAP project. They started running into capacity problems very quickly. So then the option was decided on to outsource some of the work. But what they didn't put into their plans was they didn't realize that there's a switching cost, right? Similar to multitasking, where I'm now taking some of my scarcest resources that has to bring the new resources up to speed. And that essentially reduced the availability of the top resources even more when they're already a bottleneck. So we could do a trial to say, okay, you've got currently 4 of these, say they were solution architects, right? You've got 4 of them. This outsourcing company can give us an additional 4. But we can't expect this additional 4 that has never been involved in this project to take the same task duration. So that's the first thing, right? As you said, there's maybe we've estimated 10 days when it was done by our solution architect. Probably this person will take 12 days. But there's an additional impact, which is our solution architect would have to spend 2 days of their time bringing them up to speed. So we could reduce the availability of our current resources by that amount, run the simulation. And actually what we found out was that outsourcing the work is just going to delay it even more.
Yeah, that sounds like an example of the famous fictitious work week, which was related to some of the early systems dynamic models for the rework cycle, that you got into that vicious spiral that as you got behind and rented people, the lead resources who were in the know were spending more time on inducting them and bringing them up to speed, and less work was being done. So you were Okay.
Exactly. And I think the last question to answer is, what problem are we solving with simulation? For me, there's conceptually two problems. The first one is we are facing VUCA environments in reality, right? Lots of volatility, lots of uncertainty, lots of complexity, constraints, and ambiguity in terms of objectives. We put people into those environments. The only way that they can survive is to have coping mechanisms, right? And we don't realize to what extent these coping mechanisms are causing avoidable delays. So one of the coping mechanisms is I have a standard lead time that I'm going to quote.
Yeah.
Because nobody's told me how to consider backlog into my estimation, or how to consider capacity constraints into my estimation. So simulation allows me to overcome that complexity because I can throw all the complexity at it, press the play button and see what should I have committed to, how long is it actually going to take. But there's another component to it, which is, imagine I'm giving you a set of new rules. Let's say we're implementing critical chain. There's an assumption on our side that these critical chain rules will be complied to, right? That if we tell people to not multitask, that they won't multitask. If we tell them to follow the priorities, that they will. What I can do in a simulation is I can simulate the difference between 100% compliance and 50% compliance. And that's really beneficial, is to say that I want to know if we didn't get the outcome we wanted, is it because I'm using the wrong rules? Or is it simply because there's not 100% compliance to these rules? What I can do with a simulation is I can simulate both environments.
Okay. So like a sensitivity analysis, you can actually see which rules don't matter and which do. So
exactly,
you can focus, and presumably that differs from environment to environment. So whilst the simple way is do it all and the chances are it will succeed, in the real world where you're sort of chasing whack-a-moles, you need to know which one to sit over. Okay.
Exactly. And I'll give you a simple example. Is say we had a pipeline of projects that were all 100 days long, right? Now, we would have made a simplifying assumption that says, look, we don't know the nature of the work, but probably out of that 100 days, there's probably at least 50 days of real work, and the rest is buffer, and that buffer is to absorb normal variability in the work time, right? So now the question is, should I quote 100 days and keep that full 50 days as a buffer? Or should I follow this critical chain rule that says, because of aggregation, I can now quote 75 days. I can assume that 50% of my 50-day buffer I wouldn't need because I've aggregated my buffer. That's an assumption.
Yeah.
I can now go and test that assumption. And say I've simulated with traditional project management rules and behaviors that includes multitasking, Parkinson's, student syndrome, not allowing early starts, etc. And wow, 100% of my projects were late. Now I'm implementing CCPM rules, but I'm keeping the 100-day commitment. Suddenly I'm now at 90% due date performance. 90% of my projects is now finishing on or before the 100 days. But then I can simulate it and say, what if I quoted everything on 75 days? And I might find that now I'm only at 20% due date performance. So that tells me that that assumption that I'm benefiting at least 50% of my buffer from aggregation was not true in my case. It might be generally true, but in my case, it isn't. And now I can say, okay, if it is important for me to quote shorter lead times, then what level of reduction can I make without compromising too much due date performance?
Interesting.
And I don't know of any other way of answering that question but simulation.
Well, certainly not in a project environment where feedback takes such a long time is expensive. If you're manufacturing thousands a day, You can
Yeah.
you can play, see if it works, put it back, or leave it. It takes
Exactly. You're very
decades,
true.
doesn't it?
There's fast feedback if you have short cycle times and lots of mass production, whereas in a project environment, you don't get fast feedback.
No, and it's the only way to run a realistic trial, isn't it? Is to simulate it.
Yes.
Just to finish off, Alan, because I know you spoke to me about a couple of examples of organizations you're working with that are building physical stuff. On our program, Industrial Project Management, most of our students are building assets, factories, infrastructure, labs, maybe.
Right.
So a couple of examples there, focusing on the benefits.
One interesting one was via one of my PhD students. He's head of the project system for one of the largest retail banks. Mm-hmm. And they do two types of projects. They do IT development projects, like developing a mobile banking app or enhancing their server side, etc. But they also do compliance projects. So they're constantly under pressure from the authorities to report about whether they are complying with all the standards and regulations that a financial institution has got. Yeah. So that was a really good example that they don't produce physical stuff. Mm-hmm. They develop code, they do reporting, etc. Mm-hmm. But the same principles apply, right? They've got a current portfolio, and the first question that they wanted to ask is, are we going to be able to meet our commitments? Mm-hmm. Yes or no? In those, there could be projects, there's no commitments. So one of the first questions that he said to me was, where will CCPM not bring significant benefits? Where should we rather look at something like just purely agile? Mm-hmm. And I said, for me, the difference is very simple. If you have to make commitments, it's a project environment, and their critical chain is going to be dramatically beneficial for you, because it contains things like, how do I make reliable commitments? How do I release stuff? How do I prioritize stuff in order to meet my commitments? But if it's an environment where you're doing internal IT development, right? So in my own company, we develop simulation models and apps. I don't make a commitment externally that says I'm going to have this version of the app available with this functionality by that time. And if I don't, there's going to be a penalty. I'm essentially trying to get as much done as I can. So I don't need a sophisticated mechanism for making commitments. Mm-hmm. I need a way of controlling the work that I'm doing and telling people what has to come up with, and therefore a pure agile with sprints that is not fixed time based but fixed scope based, because else I get into this horrible habit of doing 2-week sprints, when what the hell does 2 weeks mean? Does it mean that I'm now cutting off certain things and doing half jobs? No, to say, here's the scope. This scope is probably going to be a 3-week sprint. This one is going to be a 2-week sprint, etc. So that's it, to me, is another part, is again understanding, what am I trying to achieve? If I have to make commitments on time or budget, I don't have a choice. It's a project-based environment, and I need to implement all the rules, which is planning, execution, and improvement. If it's a purely production environment, it's like a project, but I'm not making commitments. I just need a way of managing the work. It's essentially an execution problem.
Yeah.
And there, something like Agile is really good at doing that.
Yeah, because you've got small batches, you've got visibility, you've got limiting work in progress, and
exactly.
Yeah, and fast feedback.
Yeah.
And finishing off, I think you were telling me about a construction business you were working with, fairly close to home, actually. I think
yes.
Where you are now. So what sort of insights did they get from modeling and simulating their environment, and what did they decide to do differently?
They had a similar situation in that there's now a peak period where there's a massive shortage in essentially middle to lower class type of condo units, and that's what they build. So for the first time, they've got more demand than supply. So they had a similar problem and they were making commitments that they realized that they were not going to meet. Many of these commitments are to large property development companies that lose money when somebody can't move in, right? So they're losing rental or they're losing the cash flow on that. So their first question was, here's our pipeline. How long is it probably going to take in reality? We said, great, give us what you've got in terms of your plan. Maybe you've only planned it at the phase level, not down at the task level. Give us your resources, etc. We ran the simulation and showed them that they were going to be late. Then the next question was, what percentage of that lateness was avoidable compared to purely task variability? And we can isolate that. And that gave us a target for improvement that says, without adding more resources, these are the delays that we could have avoided. Let's try this rule, let's try that rule, let's try that rule. Then the next portion is, we're still not meeting the commitments. Now let's thinking about resources. And what they had was, they had resources in Los Angeles and resources in Las Vegas. And to minimize transportation cost, because it's about 4-hour drive away, they were allocating Los Angeles resources only to Los Angeles work, and Las Vegas resources only to Las Vegas work. So the next thing that we could do was to say, what if we allow the simulation to assign a resource regardless of what they were originally allocated for? So if it needed a designer, there was one available in Los Angeles, let's use that one. Now, if they were required to be on site, we could then add in a transport task and an additional cost of the transportation and maybe the accommodation. But that allowed them to see, just using what we've got better, don't pre-allocate it based on some demand forecast, dynamically allocate it based on the need. And then the third simulation that we did for them was to say, they know they can get more. When do we need more? How much can we afford to pay to still make money on it? And we gave them those options to simulate. And we've done similar things in terms of R&D projects, because as you know, in R&D, there's not just uncertainty in terms of the task duration, there's even uncertainty in terms of what tasks are needed. But again, people have a general sense to say, tell me the best case, the worst case, the likely case. We can simulate all three of those environments and show you what was likely going to happen.
Excellent. Cool. Well, I really appreciate the time that you've spent with me this morning for you, Alan. Any final parting shots on things that came to your mind when we set this up that we haven't covered so far?
No, I think it's just, you know, the idea of being able to use simulations, first of all, it allows us to cope with huge amount of complexity, variability, and uncertainty, right? It helps us to consider full VUCA environments. But as you mentioned, it also helps us to provide people with insights into what will happen if I don't change anything, and what will happen if I change it. Often we see resistance to change, not because people are resisting the change, it's because I can't predict what will happen if we implement this new change. They have zero confidence in their ability to predict what will happen if we really start controlling the whip. You know, when I feel we're already late, now you want me to start controlling the whip, we're going to be even later. So using a simulation, not with generic data, but with their data, really helps them to develop that intuition about what's causing my problem and what set of rules or heuristics is best suited for solving that type of problem. And then, of course, the third component is we use the simulation for training. Because what we realize is that, you know, how long will it take me to train somebody on agile or critical change project management? And the question is, well, it depends. It depends on what? It depends on what do I need to give them to allow them to behave tomorrow in a way that benefits the system and not just their part. So I need to give them the new rules and show them how to apply those new rules. Why they should use those rules, right? And what are the various options that they've got? That's a completely different problem that you might want to take up with higher levels of management. But when you're training people at the execution level, it becomes overwhelming, right? What they need to know is Monday morning, what am I going to see? And we can show them in the simulation model is in the past, you had all of these tasks arriving. There was no clear way to prioritize. You're now going to have the following change. You'll see that right throughout this time period, you'd never have more than 3 tasks ahead of you. That's going to be the one big change that you'll notice immediately. There won't be 20, there will be 3. The 3 is going to be color prioritized. And all that you'll be asked to do is to start with the one that's in the black or the red, and then go to yellow, and then go to green. But also, we are going to ask you to change what you're reporting. We're not going to ask you to report percentage complete. If the tasks have been defined in short enough duration, all that we're going to ask you is to tell us when you started and when you completed. And just to do that as honestly as possible. And that will give us enough information to know if overall we're doing okay or not okay, and if not, why. So the simulation is a great way of showing people what a day in the life is going to look like if we implement these new rules. And also to show them the impact of not always complying to these rules. Because what we show them is that sometimes these rules are very counterintuitive from a local perspective, right? But just trust that they make sense from a global perspective. That by following these rules, you'll benefit the system. And your job is to follow the rules. So the last thing I want to just mention is that often we've seen people implement best practices like critical chain or agile, but they don't change the measurement. If you keep the measurement as, I'm going to measure you on the outcome, people will do what they believe will give them the best outcome. If we measure them purely on compliance to the rules, it changes everything. And I think that's the last part there, is to say you're not being measured on the outcome, you're being measured on, did you follow the priorities?
In effect,
did you start without a full kit? Did you multitask? These are all things. So whenever we have a rule, we have a metric to check if that rule is being complied to. And that's an important element as well.
Yeah, so you're taking away the randomness, because very often the results, the outcomes, are as much influenced by chance as they are by what you do.
And that's what's so funny with the simulation, right? We can say to guys, okay, but you've just seen this outcome with 100% compliance. What if we just tick a box and say, we just 50% of the time, they don't follow the rule? What will happen? Oh my God, everything will take long. Okay, so guess what? In future, it's really important that people comply. And if they can't comply, they must tell you, right? You've asked me to follow the priorities, but I can't because I don't have what I need to start with a red task. Is it okay if I start with a yellow task? Absolutely. But as soon as we've got everything that we need for the red task, please go back to the red task.
Thank you very much for your time, Alan. And on behalf of our students,
you're most welcome.
And myself, and I'll wish you a great day.
And I've already committed to you. We've got a whole bunch of these simulations, some of them very simple, and we're going to make that available to the students to play around with while they're studying. And they can, as academics or students, they can buy these for 50% discount. They're already really marked down. So we'll make it available to all the students that they can play around with the various simulations.
That's brilliant. And I'll include full details of that when we upload this onto Canvas. Thanks, Alan.
Awesome. Okay. Thanks, Ian. Bye-bye.